Namaste everyone, welcome to the class again. Now in this lecture we will see first a property of Laplace transform that is called linearity property. Now this linearity property is very simple. If we take k1 and k2 as constants, then Laplace transform of k1 into f1t plus k2 into f2t is equal to k1 into Laplace of f1t plus k2 into Laplace of f2t. Okay, so what we done here, we split this part for Laplace. We have to take Laplace of this whole term, that means we have to take Laplace of this part plus Laplace of this part. When we are taking Laplace of this part, we can take k1 out of that Laplace, and k2 similarly we can take out of that Laplace. So we will understand this when we solve few problems. So let us first understand Laplace transform of some standard functions. So here we will discuss Laplace transform of some standard function. Now derivation of all these functions is not that important, but their formulas you have to learn. Like if I consider my function as a constant, so if I take function, if f of t is say k, then what is Laplace of f of t? Question mark. We know the definition. Now when I am saying f of t is equals to k, here I am not mentioning any limit. That means this is applicable for all real numbers. So I will say Laplace of f of t is equals to, our formula is Laplace of f of t is what? 0 to infinity e raised to minus st into f of t dt. So here it will become 0 to infinity e raised to minus st into f of t is k into dt. Now k is constant, so we can take out. Integration of e raised to minus st is e raised to minus st divided by minus s. Limit we put 0 to infinity. This is equals to minus k upon s, this I will take outside. Then here it is e raised to minus infinity minus e raised to 0. We know the value of e raised to minus infinity. The value of e raised to minus infinity is 0 minus e raised to 0 is 1. So the final answer is k upon s. So Laplace of f of t, that is Laplace of k, is equals to k upon s. So whenever there is a constant number, its Laplace is simple. Say if I say that Laplace of 5, so then answer is 5 divided by s. Laplace of 1, then it is 1 divided by s, right? Okay, so this is first standard function. Whenever your function is a constant function, then its Laplace is going to be constant divided by s. Now let us take one more function. Second, let us find Laplace of e power at. That means here we are taking f of t as e power at. So again I have Laplace of f of t, that is Laplace of e power at, is equals to 0 to infinity e raised to minus st into e raised to at into dt. Our function f of t is e raised to at. So here this becomes 0 to infinity e raised to, this is minus st plus at into dt. So this is 0 to infinity e raised to minus, I will take minus sign common, so here it is s minus a and I will take t common. Now one point to be noted here is that I am taking minus sign common. Okay, you can do this without taking minus sign common, but it is recommended to take minus sign common, as after integration we have to take the limits, and e power minus infinity if we are getting, then its value is 0. So it is easy to calculate. So here, so always whenever limit is 0 to infinity and e power is there, so try to make it as a negative power. So after integration I will get e raised to minus s minus a times t whole divided by minus of s minus a, and the limit is 0 to infinity. So when I put upper limit in place of t, when I put infinity, it become e power minus infinity, which is 0. Minus when I put 0, so e power 0 is 1, so it become 1 upon minus of s minus a. Now this minus minus will cancel and final answer is 1 upon s minus a. So now you have to learn this result, that Laplace of e power at is equals to 1 upon s minus a. In the same way we can prove that Laplace of e power minus at. So what we are doing, we are replacing a by minus a. So here also in the same way we will replace and we will get Laplace of e power minus at is 1 upon s plus a. Next standard function is f of t, when f of t is equals to sin at. So Laplace of sin at will be equal to 0 to infinity e power minus st into sin at into dt. Now we have the formula, it is 1 upon s square plus a square. Actually this is minus s the whole square, but minus s the whole square is s square only, so we are writing s square into e power minus st into, here we will write minus s into sin at minus a into cos at, and then our limit, which is 0 to infinity. Now when we put infinity, it becomes e power minus infinity, which is 0. So 0 minus, here when we put 0, e power 0 is 1, so it is 1 upon s square plus a square, and here inside bracket when I put 0, sin 0 is 0, so this first term is 0, minus a into cos 0 is 1, so this is 1. So this minus minus will plus, so final answer is a divided by s square plus a square. So this is the value of Laplace of sin at. Laplace of sin at. So Laplace of sin at is a upon s square plus a square. Again you can remember this. And the same way you can prove for Laplace of cos 80. Now when you do derivation for Laplace of cos 80, you will get s divided by s square plus a square. Now the next standard function is Laplace of sine hyperbolic 80. Now sine hyperbolic 80, we know that sine hyperbolic 80 can be written as, so here we should know that sine hyperbolic 80 is nothing but e power 80 minus e power minus 80 whole divided by 2. Okay, so to find Laplace of sine hyperbolic 80, I will say that Laplace of sine hyperbolic 80 is same as Laplace of e power 80 minus e power minus 80 whole divided by 2. So 1 upon 2, that linearity property, any constant term we can take out, into Laplace of, we can say, e power 80 minus 1 upon 2, or what we can do, this 1 upon 2 we can take out, okay, and we will use a big bracket, and here it is Laplace of e power minus 80. So we know the value of Laplace of e power 80, just now we have find out its value, it is 1 upon s minus a minus 1 upon, this is s plus a. So when we simplify, we get 1 upon 2 s plus a minus, here in bracket I will say that s minus a whole divided by, here it is s minus a into s plus a. So this is equals to 1 upon 2. Now here we have s plus a minus s plus a whole divided by, here it is s square minus a square. Now this minus s and plus s will cancel, and here we have 1 upon 2, a plus a is 2a divided by, here denominator is s square minus a square. Now this 2 and 2 will cancel, and our final result is a divided by s square minus a square. This is Laplace of sine hyperbolic 80. In the same way, we can find Laplace of cos hyperbolic 80. Laplace of cos hyperbolic 80, we will get s upon s square minus a square. So we have done Laplace of sine hyperbolic 80 and Laplace of cos hyperbolic 80. Now let us see one more, Laplace of t power n. Now Laplace of t power n, so here we use the formula, this we have to find out. So we will say that we will apply the basic definition. Laplace of t power n is equals to 0 to infinity e power minus st into t power n into dt. Now here we have a concept of beta gamma function that we will already done in our first year engineering. So here for that we will put this st as z. So here we will do some substitution. Okay, here we say that let this st as z, therefore t will become z upon s and dt will become 1 upon s into dz. Our limit, okay, as t tends to 0, z will tend to 0, and as t tends to infinity, z will tend to infinity. So my variable will change. This will become 0 to infinity e raised to minus z into t will become z upon s the whole power n into 1 upon s into dz. Now here variable is z, so I will take all s term out. So 1 upon s power n plus 1, here s power n and here 1s, so 1 upon s plus 1, it is gone out and we have 0 to 1 e raised to minus z into z raised to n into dz. Now by using beta gamma function we can write this whole part 0 to infinity, sorry, this is 0 to infinity, we can write this whole part as gamma of n plus 1 whole divided by s power n plus 1. Now if n is positive integer, then this gamma n plus 1 can be written as n factorial upon s power n plus 1. This is when your n belongs to integer, positive integer. So when n belongs to positive integer, we can say this as n factorial upon s power n plus 1. So we have Laplace of t power n as, so Laplace of t power n is gamma n plus 1 upon s power n plus 1 is equals to n factorial upon s power n plus 1. So mostly you will encounter with positive values of n, so directly you can say Laplace of t power n is equals to n factorial upon s power n plus 1. Now there is one or two more standard formulas, but that I will not discuss here. The derivation I will discuss in some other class. Okay. Now using this, let us solve few problems. First problem which we will discuss is, if we want to write all the formulas at one place, let us first write that. So I will see that list of Laplace transform. So some standard formulas we are going to see. First, Laplace of, I will say, k. Laplace of k is what? K upon s. Second, Laplace of e power at. It is 1 upon s minus a. Third, Laplace of e power minus at. It is 1 upon s plus a. Fourth, Laplace of sin at. It is a upon s square plus a square. Fifth, Laplace of cos at. It is s upon s square plus a square. Sixth one, Laplace of sin hyperbolic at. It is a upon s square minus a square. 7th, Laplace of cos hyperbolic at. It is s upon s square minus a square. 8th one, Laplace of t raised to n. It is gamma n plus 1 divided by s power n plus 1. Now few more standard formulas which I have not discussed their proof is Laplace of error function of root t. This is equals to 1 upon s root of s plus 1, and last Laplace of error function of complement of root t. This is equals to 1 upon root of, here s I will replace by s plus 1, and here inside also I will replace s with s plus 1. Here there is a little mistake. This 1 upon, this is s into root s plus 1, it is like this. So here when I replace it for complement function s by s plus 1, it will be root s plus 1 plus 1, it is something like this. Okay, so these are few formulas, okay, that we should remember. This is same as in derivatives. In derivatives what we done, first we have find out the standard functions derivative by using first principle, and then we learn them to be used in our problems. In the same way we are going to now use these formulas in our problems. Let us see one problem. So first problem which I will discuss with you is cos hyperbolic square 4t. I have to find Laplace of cos hyperbolic square 4t. Okay, so as we have formula in circular function, sin square theta is 1 minus cos square theta. We have sin square theta, also one more formula, 1 minus cos 2 theta upon 2, and sin square theta cos square theta is 1 plus cos 2 theta upon 2. So in the same manner we have for hyperbolic functions. Now here also, as in integration, we try to convert all the given functions in a form whose integration we can find out. Similarly here we have seen these standard formulas. Our what we can say that our aim should be to convert them in the form whose Laplace we already know. So here we know Laplace of sine, cos, sine hyperbolic, cos hyperbolic, like that. So this cos hyperbolic square I need to convert in that form. So here this Laplace of cos hyperbolic square 4t I will write as, this is equals to Laplace of 1 plus cos hyperbolic, this will become 80 and whole divided by 2. So Laplace of cos hyperbolic square 4t is 1 plus cos hyperbolic 80 whole divided by 2. Now here 1 upon 2 we can take out, and using linearity property we can write this as Laplace of 1 plus Laplace of cos hyperbolic 80. So we know what is the value of Laplace of 1, it is 1 upon s, and Laplace of cos hyperbolic 80 is s upon s square minus a square. So here 8 square we will say. So then this is our final answer. If you wanted to simplify it further, it is your wish. Otherwise, we have arrived at the answer. Done? Okay. Now let us see one more question. Second question. Laplace of cos t cos 2t into cos 3t. Now what we do? Okay, so we have to convert this cos t, cos 2t, cos 3t in some standard form. Okay, some standard form. So for that, let us revise the formulas which we have, which we know. Okay, which we already know. So what are those formulas that we already know? Trigonometric formulas. Let us revise that. So here, first formula that we are going to revise is cos A into cos B. So let us revise cos A into cos B. What is the value of cos A into cos B? Yes, any idea what is cos A into cos B? Yes, cos A into cos B. It is 1 divided by 2. Okay, actually the formula is 2 times cos A cos B. So if I want to find cos A cos B, it is 1 divided by 2 cos of A plus B plus cos of A minus B. Right? Cos A cos B is 1 upon 2 cos A plus B plus cos A minus B. Similarly, we have sin A sin B. So when I say sin A sin B, then it is sin A into sin B. Now this is 1 by 2 into cos, we will take cos A minus B first, minus cos A plus B. In the same way, third formula which you should know is sin A cos B. So sin A cos B is 1 upon 2 sin of A plus B plus sin of A minus B. And fourth one is cos A sin B. So this is 1 by 2 sin A plus B minus sin A minus B. So here it is minus sin A minus B. So at least these 4 formulas means, as we will do problems, we will see one by one different formulas. That formulas you can write at one place, or I hope you must have a list of formulas like this. Okay. So now here cos t cos 2t into cos 3t. First let us find the value of cos t into cos 2t into cos 3t. So this is equals to, first we will solve this part. So this will become 1 upon 2 cos of a plus b, that is cos 3t, plus cos of a minus b. So t minus 2t is minus t, but cos minus theta is cos theta. So I will write cos t. Now this whole term is multiplied by cos 3t. So this will become 1 upon 2. Here we have cos 3t into cos 3t, that is cos square 3t, plus we have cos t into cos 3t. So this is 1 upon 2. Now we will apply the formula for cos square theta, which is 1 plus cos 2 theta, that is cos 6t whole divided by 2, plus here it is 1 by 2. Inside bracket we will say that cos of a plus b, that is 4t, plus cos of a minus b, that is cos minus 2t, but it is same as cos 2t. So 1 upon 4 is outside. Now we have here 1 plus, in order I will write as, first I will write, let us cos 2t, then I will write cos 4t, and then I will write plus cos 6t. So this is the value of cos t, cos 2t and cos 3t. So therefore Laplace, when I have to find Laplace, I will say that Laplace of cos t into cos 2t into cos 3t. Laplace of cos t, cos 2t, cos 3t, this is equals to 1 upon 4 we can take out, and here inside we have Laplace of 1 plus Laplace of cos 2t plus Laplace of cos 4t plus Laplace of cos 6t, then I will close this bracket. So this is equals to 1 upon 4 Laplace of 1 plus Laplace of cos 2t. So what is the value of Laplace of 1? Laplace of 1 is 1 upon s, plus Laplace of cos 2t is s upon s square plus 2 square plus s upon s square plus 4 square plus s upon s square plus 6 square. So this is our final answer. This is Laplace of cos t, cos 2t and cos 4t, right? So you have an idea that how we can proceed for these problems. Now sometime you will see that in your textbook this part is simplified further, and sometime they stopped here. So I think we can stop here, as our main objective here is to find Laplace of a function and not to find its simplification. The simplification form we have already learned in our lower standards, but then also, okay, as in many books it is simplified, so I recommend that you also simplify wherever it is possible. Okay, so I will give you one question to try by yourself, and then I will end for the day. So here for you have to find Laplace of sin power phi t. Now this question is an important question. Many times it is asked in exams. So try it yourself. Otherwise in next class I will show you how to get the Laplace of this sin power phi t. So here in this lecture what we have done, so we have seen a Laplace transform of some standard functions, and we have seen two problems, okay, in which we have applied those standard formulas. So our next lecture will be based on this concept only, कि how we can use these standard Laplace transforms in the problems. Okay, thank you for being with me in this lecture.